today's lesson, we're in section 4.4, and this is again pre-algebra, talking about graphing inequalities today. This is on page 158 in the textbook. And so first let's talk about what an inequality is. So we kind of know what equalities would be. That would be things that are equal to each other. So an inequality sounds like it would be something that's not equal. So if things are not equal, we need to have some other way to express how they relate to each other. So we've done inequalities before in earlier grade levels. So for example, we're familiar with this symbol. That would mean that things are equal to each other, right? My little quotation marks. We've seen this guy. All right, you may have heard the crocodile story or something like that to help us explain our little birdies in early math classes, that this symbol read from left to right. We see the larger end is first. This would be referred to as greater than. If we switch it the other way, we could then go left to right and see that the smaller end is first, showing that this is a smaller value on this left side. We would say less than. But there are some other ways to express relationships between numbers that's kind of in between being equal or one of these others. And that symbol could look like this, where it has a greater than symbol and part of the equal sign. That could say that, well, I may not know exactly what the number is, but the number is, this value is greater, or it could be equal to the value, okay? So this would be greater than or equal to. And likewise, the other direction, if we have the less than symbol with the portion of the equal sign, it could say that that value is less than or equal to the other value. So less than or equal to. Okay, and so sometimes visually it helps to see what this would look like on a number line. Like how could you have a number that's less than or equal to? One more symbol. If it's the complete opposite of being equal to something and it's not equal to, they use the equal sign with a slash. And this would be not equal to. All right, I think I got all the symbols now. We're ready now to take a look at the number line and how this would look. I'm going to slide this over. So we could have an inequality. Before we would have like numbers like maybe 3 compared to -2, right? And we would say, well, which symbol could we use here? Well, in this case, we can see clearly that 3 is greater than -2. So we could use a symbol that's greater than, right? But now we also have the ability to say, well, we could say that it's greater than or equal to, because it only has to fill one of these to be true. So I could say that it's greater than or equal to. Now it's not equal, but it is greater than. I could even say that it's not equal to. So we have a few different ways to show comparison of our values with these additional symbols. This becomes more understandable as to, well, why would you need so many symbols? Well, when we start to incorporate variables that I don't know the exact value of, that I might say that x is greater than 5, okay? Well, I don't know exactly what number x stands for, but I do know that it could be any number that's greater than 5. I could say that I have another number, x, and this time I'm saying that it's less than or equal to 3. Well, I know that x is either smaller than 3 or it could actually be equal to 3. And so this lesson today, we're going to be graphing these inequalities. And so rather than having to say an actual value that it has, these are going to have a range of values. That there are lots of numbers that are greater than 5. There are lots of numbers that are less than 3. So let's take a look at how we will represent those. So on the bottom of page 158, they have a little bit of a chart there to kind of help us visualize how we could graph these. And so I'm going to make a little note here that if I want to show that a value is greater than some value, we're going to use an open circle, or what they're calling in your book an open dot. I'm sorry. An open dot. That could be for greater than, it could be for less than, okay? But if we have a less than or equal to, or a greater than or equal to, we will use a filled dot, or what they're calling a closed dot in your book. So use a closed dot. And I'll explain a little more what that means when you see the graph. So in order for us to show an inequality on a number line, this is the same number line we talked about when we were first reviewing integers, right? We have positive numbers to the right, we have negative numbers to the left, and they go infinitely in both directions. That's why we have the arrow there. And let's say we had the inequality that says x is less than 2. All right? So, because it's less than, it doesn't have an equal sign to it, we're going to use an open dot on the number line. So I know the value 2. It's not actually going to equal 2. It's anything that's smaller than 2. So I'm also going to shade on the line representing the values that are less than 2. So now I have a picture that shows me all the possible values that x could be. X could be any value that is less than 2. And it's open because it's not actually equal to 2. Well, let's see what it would look like if we had a closed, if we needed to use a closed dot. So similar number line. With some positive numbers on the right and negative numbers on the left. And this time, let's say we have a value of x is greater than or equal to 2. Okay, so again, our value is 2, so we'll find this positive 2 on the number line, but this time we're going to fill in the dot because we have the equal to under it, because it actually could be the number 2. It could be 2 or any number larger than 2 or greater than 2. So we're going to shade this side where the values get larger on the number line. So we have just graphed the inequality. Okay, you have to know whether or not to use a open dot or a closed dot based on the symbol that's in the middle. And then you will shade depending on whether it's the values less than or the values that are greater than. Okay, so let's see. They have a chart with several different versions of this here. Let's just do some examples. I am looking at example 4.4a. And the first one has x is less than -4. Okay? Now, if you're sketching, you don't have to have a ruler like I had. You could just, draw a little number line. You don't have to fill in all the numbers. You just need, enough to represent what you're showing. So I see that I need a -4. So I know I'm going to have -4 somewhere on there. I'll give a few numbers, before it. I'll give a few numbers after it. Oops, I went the wrong way. Talking and writing sometimes gets interesting. So -4, -3, -2, -1, 0. This way will be -5, -6. And I'm showing what is happening right at -4. I don't have the equal sign under there, so my dot is open. I see that the values are smaller than -4, so I'm going to shade the side where it gets smaller, just like that. And another example. Now this one's not the same example from here, but it is one that's like on the little chart on page 159. And it says, what would you do if they gave you something like x is not equal to a certain number? Okay? What if they wanted us to show that x was not equal to 4? Again, I'm just filling in a few numbers before and after. I see that it cannot be equal to 4. Like, basically it's saying x could be any other number except for 4. So for this situation, we're going to have to leave it open at the number 4 because it can't include 4, but it could include every other number larger or smaller. Okay? This would be the value of something not equal to. If we had the value as equal to, let's say we had, x equals 4. Well, we've done this before. Again, when we had the lessons, we were first getting acquainted with the number line. We were just locating, where is this number on the number line? X equals 4. Well, if it equals 4, it's only equal to 4. It's not anything before or after, it's just the number 4, okay? So hopefully this gives you some basic understanding of the graphing of inequalities when there's just one inequality. The next example shows what to do when there's more than one inequality symbol. And this is example 4.4b. And the example they have is -5 is less than x, which is less than or equal to the number 2. This is called a compound inequality because there's two things happening here. So for me, the easiest way to work this is to first just ignore the front portion and just focus on this part first. Well, it says that x is less than or equal to 2. So I will go to my number line. I know I'm going to need -5 and I'm going to need +2. So I'll go ahead and put those in. Okay, and again, just a couple numbers before and after so we can identify which direction to shade. But first, starting with x is less than or equal to 2, the equal to under there tells me to go to +2 and put a filled dot. Once I have that, I'm now going to look at the other direction and kind of read it backwards. It's basically saying that -5 is smaller than what x could be, or x has to be bigger than -5. Okay, whichever makes more sense for you as you look at this. But basically we're saying that x could be, you know, as small as -5 or as, you know, up to and including 2, right? So I would go at -5. It doesn't have the equal to under it, so open dot. And we were saying that x is less than or equal to 2, so it's shading this way. And then it's saying that -5 is less than x, so x can't go any further than -5 or lower than -5. It's just the value in the middle. So this is the graph for our inequality, our compound inequality. Let's look at one more from this example set. They've also got 0 is less than or equal to x, which is less than 4. Again, number line, and we'll put both numbers in there. We'll put a 0, 1, 2, 3, 4, 5. We'll put a couple negative numbers in there. And let's take a look. Well, first off, I see at 4, it's going to be an open dot because there's no equal to there. But at 0, it's going to be a closed dot because of the equal to. And now I'm verifying that, yep, x is smaller than 4. And then it has to be, you know, no smaller than 0 because it has to be, because 0 is less than or equal to x. All right. And the last thing they'll do, they may give you the graph and then ask you to create the compound inequality. So I'll do one of those, and that should do it for our notes. And example 4.4c. And we're starting off with the graph. This one is letter B of that example. Let me get it sketched up here first. And this is what they have. They have a closed dot here, open dot here, and then it's filled in the middle. All right, so we know we have a compound inequality because it did not shade all the way to the arrows, okay? So here we go. We're going to start with kind of reading it left to right. We're going to start here. We've got 1. And we know that it could be equal to 1, right? So we need that equal to there. We need our variable x. And it stops at 3, but it's not equal to 3. So I see that x is a value that's less than or equal to 3, and it can't go any lower than 1, but it could actually be 1. Okay, so you'll get some practice with graphing the single inequalities and the compound inequalities, and also going the other direction with identifying the graph to give the original inequality.